Another desk scheduling algorithm is shortest seek time first. In this algorithm, 200 tracks given with a request queue, and the request queue is starting from like 87, 170, 40, 150, 36, 72, 66, 15. Okay, now what is the meaning of shortest seek time first? In that case, we consider the nearest job with respect to our head. Now in this question, head is given, the head is 60. That means we have to find out the shortest job or the nearest job of 60. So in this queue, here we see that the nearest job of 60 is 66, right? Here the spiral mode of disk track is converted into a straight line for easy calculation. Now according to SSTF rule, we find out the nearest job according to our head. Here the head is 60. We already discussed that the nearest job of 60 is 66, right? That's why it's starting from head, that is 60, and move to the next nearest job, that means 66. In this request queue, we find that the nearest job of 60 is 66. Okay, so the head movement calculation is head movement 60 to 66. So the gap is, or the movement gap is 6, right? Next we find out the nearest job of 66. Now in this request queue, we find that the next nearest job of 66 is 72, right? That's why we have to move next nearest job, that is 72. Again we calculate the movement, that is the next head movement from 66 to 72. So 72 minus 66, the gap is again 6, right? Next head movement or next nearest job of 72 is 87. Again we calculate the next movement, that is movement 72 to 87, and the range is 15. Okay, again what is the nearest job of 87? So the nearest job of 87 is 40, because the gap of 87 to 40 is 47. But if we consider the another gap, that is 87 to 150, the gap is almost 63, right? According to SSTF algorithm rule, we have to consider the nearest job. That's why we consider here the next nearest job of 87 is 40. Now here we draw the next nearest job of 87 is 40, right? And calculate the movement. The movement is 87 to 40. 87 minus 40, so the gap is 47. Next nearest job of 40 is, in this queue, is 36. So here we write the next nearest job of 40 is 36. Now we calculate the movement. So the movement is 42, 36, so the gap is 4. Next we calculate or consider the next movement or next nearest job of 36. So in this queue, here we find that next nearest job of 36 is 15. So we draw the movement, that is 15. Again we calculate the movement, that is 36 to 15. The gap is 21. Next we find that next nearest job of 15. Now in this queue we see that 87, 40, 150. When we calculate the nearest job of 15, in that case we have to recheck the queue. So in this ready queue we see that the 87, 40, 36, 72, 66 and 15, already those jobs are processed. Only 150 and 170 are remaining. So when we consider the value is 15, in that case 150 is nearest. That's why we have to move this job 150 scale. Okay, so the movement is 15 to 150 and the gap is 135. So the next nearest job of 150 is 170. Next movement we have to draw 150 to 170 and calculate the gap, that is the movement is 150 to 170 and the gap is 20. So the total value of head movement is 244 cylinder. Now in this question we see that here we calculate the average seek length using SSTF algorithm. So when we calculate the average seek length, at that time we have to count the movement, that is 1, 2, 3, 4, 5, 6, 7, 8. That's why here we divide the total movement by 8 and the value is 30.5 cylinder. Okay, up to this we cover one of the problem of a shortest seek time first. Okay, here we consider the another example of SSTF, that is the shortest seek time first. In this question again 200 track is given and the ready queue is starting from 98, 183, 37, 122, 14, 124, 65 and 67, and also the head is given, the head is 53. So the disc track is 200, that's why it's starting from 0 to 199. Now in that case here we see that the head is 53. So according to SSTF algorithm we have to find out the nearest job of 53. So the nearest job of 53 is in this queue, here we find that 65. That's why we have to draw the nearest job of 53. That means if it's starting from this point, this is 53, so the head movement is 53 to 65, right? And calculate the head movement. That's why here we write the head movement 53 to 65. So the gap is 65 minus 53, 12. Okay. Next movement or next nearest job of 65 is in this queue. Next nearest job of 65 is 67, right? That's why here we point out the 67, and again we calculate the movement, that is 65 to 67. Gap is 67 minus 65 is 2. Next we have to find out the nearest job of 67. So the nearest job of 67 is 37. So here we write the value is 37, and again we calculate the head movement, and the head movement is 67 to 37. So the gap is 30. Next we have to find out the next nearest job of 37. So the nearest job of 37 is in this queue. Here we find that next nearest job of 37 is 14. That's why here we write or draw the next nearest job of 37 is 14, and again we calculate the head movement. So the head movement is 37 to 14, and the gap is 23. Now when we calculate the next nearest job of 14 in this queue, we see that 37, 14, 65 and 67 are already processed. So we have to consider the next bigger value. That's why we have to move in the next position. Now in this queue we see that 98, 183, 122 and 124 are remaining. That means those jobs are not processed. That's why when we consider the nearest job of 14, in that case the remaining job, that is 98, is nearest. Here we draw the next nearest job of 14 is 98. Now calculate the head movement. So the head movement is 14 to 98, and the gap is 84. Next nearest job of 98 is 122. That's why here we draw the next nearest job of 98 is 122, and again we calculate the gap, that is movement 98 to 122, and the gap is 24. Next again we have to find out the next nearest job of 122. Here we see that 124 is the next nearest job. Again we calculate the head movement in the similar way. Movement is 122, 124, and the gap is 2. Next nearest job of 124 is 183. So we draw the next nearest job 183 and calculate the gap, that is the movement 124 to 183, gap is 59. Here we see that all the job are processed, there is no remaining job. Then we calculate the total number of movement. So total number of movement is 236. So when we calculate the average seek length of SSTF algorithm, then we consider the total head movement So the total head movement is 1, 2, 3, 4, 5, 6, 7, 8. That's why here we divide. The total head movement is divided by 8 and the value is 29.5. So the average seek length using SSTF is 29.5. Up to this we cover the SSTF algorithm. Okay, thank you.